Continuing with Unit 3, we're going to look in this video at requirements prioritization, validation and change. We're going to explore why the process of requirements elicitation can be difficult, and we'll also look at what is meant by each of our key terms. Looking back to the process of requirements engineering, there are 4 stages, and we're going to begin by focusing on the second, requirements elicitation and analysis. Elicitation, if you remember, entails finding out what the customer wants of the system. We need to find out, or elicit, what they require. This is a challenge for a number of reasons. Firstly, customers might not know exactly what they do require. Secondly, they might express their requirements using terminology that exists within their own professional domain. A system to be used in a medical context, for example, might be expressed using medical terminology with which the requirements engineer is unfamiliar. This problem can be exacerbated if multiple stakeholders express the same requirement in different ways, or a range of differing requirements using the same term. Then there's politics. Does the manager require that feature to meet the needs of their organisation, or are they trying to increase their influence within the organisation? Also, the context in which an organisation operates is not fixed. A changing economic landscape can cause a change in the priority of certain requirements, or perhaps necessitate additional requirements. For these reasons, requirements elicitation and analysis is best viewed as a cycle rather than a single-use process. Interact with the stakeholders, group identified requirements coherently, identify and resolve conflicts between requirements with the help of stakeholders, produce documentation, either a draft of the requirement specification or simply a list. Then, around we go again, with a view to refining these requirements. Any misconceptions or conflicting requirements can be addressed by repeating this cycle. In terms of stages and documentation, this cycle is located here, within the requirements engineering process. Prioritization, in any context, means ranking outcomes according to their importance. Here we use Moscow criteria, another acronym, but one in which we ignore the O's. Must-have criteria are essential, and the project would be a failure by failing to meet any one of them. Perhaps the system would be unsafe, or would fail to meet a legal threshold. Should-have criteria could be omitted, but ideally won't be. Criteria of this class can be missing, and the project can still be a success, but some sort of workaround might be needed, or the project might not be as efficient as it could be. Perhaps file sharing is required, but cannot be delivered in the current iteration. In this situation, the problem can be addressed by sharing files in some other, less efficient way. It's not ideal, but the system still works. The could-haves are optional, and the want-to-haves or won't-haves will not be implemented. They're useful to discuss, as they help customers and developers to see the dividing line between what a project will do and what it won't do. We can't simply list all criteria as must-have. This approach lacks flexibility and invites failure, and there is often not sufficient time or budget to do everything. If we can't meet every criterion for every project, prioritizing helps to ensure that any missed criteria do not result in a failed project. Priorities do not necessarily remain fixed throughout the life of a project. A must-have might not be a must-have in the first iteration, as the intention might be to implement it during the second. A should-have might become a could-have if its importance is reassessed. What won't happen is the downgrading of a must-have for the whole project, since this is essentially making a decision for the project to fail. Typically, when translating priorities to effort, the must-haves occupy 60%, with the should-haves and could-haves occupying 20% each. The want-to-haves, remember, have been agreed to not be implemented. Effort in this context would be defined as the time, budget, human resources and other resources dedicated to each level of priority. Of course, if the must-have requirements need more resources, they will gain them, typically at the expense of the could-haves. We need a way of assigning priorities. We might start by saying that all criteria are want-to-have, before examining each one in turn, justifying any move to a higher priority. For any entering the must-have bracket, a question must be asked. Would failure to deliver this criterion constitute failure of the whole project? If the answer is yes, then there it stays. If the answer is no, it's really a should-have or a could-have. We might discover that a criterion is actually 2 or more criteria, which should be decomposed before each is individually prioritized. If a must-have depends on another criterion being implemented, that other criterion should also be must-have. Otherwise, an essential criterion depends on the completion of a criterion which, by virtue of its priority, might not be implemented. One criterion might have multiple levels of acceptability, each with their own priority. The system must reflect changes based on data entry within 1 minute, but it should do so within 5 seconds. When documenting requirements and their priorities, you should bear 4 things in mind. Each requirement should have a unique identifier. Each requirement should be described, typically beginning with "the system shall." Each requirement should be prioritized. Requirements should be sensibly grouped, although there is often more than one way of grouping. You should include both functional and non-functional requirements. Requirements validation is the process of answering the question, have we got the customer requirements right? This is not a straightforward question because there are several ways of getting them wrong. Have we captured the real needs of the user? Are we free of conflict between the requirements? Is everything needed actually captured in the requirements? Can this be done within budget and on schedule? Is our document unambiguous, interpreted by developers and users in the same way? Are our requirements specific and measurable? Review sessions with all stakeholders will help to ensure that the answer to each of these questions is yes. So, why do we care enough to validate? Why not simply have a process whereby the user tells us what they want and we develop it? Surely that would be quicker. Well, yes, but requirements validation does reduce the instance of errors. The earlier in the process an error is detected and resolved, the less expensive that resolution is. Much less expensive. Let's talk about requirements change. We live in a fast-paced world, and requirements analysis is not exempt from that. The nature of the problem might change. The stakeholders' understanding of the problem might change. The budget and timescale might change. And when one requirement changes, it can have a knock-on effect on its dependent requirements. Traditional processes can address changes in requirements, but there can be rigidity. Changes come at a cost in terms of both budget and time, although conflicts and other problems are managed carefully. Lots of changes arriving in succession can cause problems for such an approach. Agile processes, on the other hand, exist with change in mind. There is no detailed written requirement specification, so the user can easily change the priorities, although this can run the risk of derailing dependent criteria. That brings us to the end of this support video. The recommended reading associated with this topic is on the screen now.